let's study what isotopes and isobars mean. What are isotopes? See, we find that ele- elements like contradicting what Dalton's atomic theory says, which says that uh, atoms of same element are are identical in all the ways, but it differs from atoms of other elements, right? But here we find that atoms of same element also have different properties. They have different physical properties, although their chemical properties are same. For example, the hydrogen, the normal hydrogen, the 99% of hydrogen that we find in nature is this hydrogen, which is also called protium. It has it has one proton. That's why its atomic number is one. So number of electron is same. Number of electrons is also one, but it has no neutron in the nucleus. So one proton, one electron, and no neutron. So this particular kind of atom, a hydrogen atom, is called protium. Now there is one more hydrogen atom in which there is one neutron. So the number of the mass number, it becomes 2. 1 plus 1. Atomic number is 1 itself. So and there is one more electron, one more species of one more kind of hydrogen atom in which there are two neutrons. So the mass number becomes 2 plus 1. Number of proton is 1. Number of proton is same. That means the element is hydrogen. But the mass number of these three species, they differ because they have different number of neutrons. Here there is no neutron. Here there is one neutron, and in this case there are two neutrons. So the mass number is 1. 1 plus 0, 1. Here 1 plus 1, 2. Here 1 plus 2, 3. This is called protium, this is called deuterium, and this is called tritium. So these are three different kinds of atoms of the same element. So they are called isotopes. So isotopes of an element are atoms which have same atomic number but different mass number. The difference is mass number is due to the difference in number of neutrons, right? So what determines an element? What determines an element is its atomic number. Find atomic number. Atomic number is 1. That means the number of protons, or that means the number of electrons in the neutral atom. That determines the atomic number, not the number of neutrons. Number of neutrons may differ. Due to difference in number of neutrons present, there will be isotopes of an element. Similarly, there are isotopes of oxygen, there are isotopes of carbon, there are isotopes of chlorine. So isotopes of oxygen is oxygen 16, oxygen 17, oxygen 18. But their atomic numbers are same, 888. That means they have same number of protons, but different number of neutrons. We are not talking about number of electrons. It will be same as number of protons in neutral atom. There will be 8 proton, 8 electrons, 8 protons, 8 electrons, 8 protons, 8 electrons. But what about this? This is the sum of number of protons and number of neutrons. It's 16, it is 16, mass number 16, it means there are 8 protons and 8 neutrons. Here, 8 protons, but 9 neutrons. And here, 8 protons, but 10 neutrons. Because of that, the mass number is 18. So these are isotopes of oxygen. So these are isotopes of carbon 12, carbon 13, carbon 14, all having the same. So isotopes are atoms having same atomic number but different mass number. Difference in mass number is due to difference in number of neutrons. Now, chlorine has two isotopes, chlorine 35 and chlorine 37, which differ in mass number, and it is due to difference in number of neutrons. And how will you calculate number of neutrons? Just subtract the number of protons or atomic number from the mass number. You'll get number of neutrons. You see number of neutrons there. The difference of 2 neutrons. It has two more neutrons than this. So very important thing about one more thing that you can note down over here is that the chemical property of of oxygen is different with the chemical property of carbon. Why? It's not because of number of proton or neutron. Chemical property depends on the number of electrons which are there in the outermost shell of an atom, or in number of electrons. Since the number of electrons in all these species are same, so they have same chemical properties. All they differ is in their physical properties. Maybe one is heavier than the other, right? Not in their chemical properties. Isotopes have same chemical properties because the species have the same number of electrons, and chemical property depend on number of electrons, not on number of protons or neutrons. So they have same chemical property but physical different properties. What about isobars? People many times students can have like confusion between isotopes and isobars. Isobars means that atoms which have same number of same mass number but different atomic number. Since they have different atomic number, they will be different elements. So example here, carbon 14 and nitrogen 14, they are isobars because they have the same number of they have same mass number, but their atomic numbers are different, means they have different number of protons in their nucleus, and maybe they have different number of neutrons too. But overall, the number of the nucleons, or the number of protons and neutrons, now the sum of the number of neutrons and protons in these two species same. So they are called isobars. Isobars will be chemically different because they have different atomic numbers, when they have the number of electrons in them are different. So they have uh, different chemical property, or maybe physical property, maybe or may not be same. Fine.